Picture this. You are standing in the middle of a massive high-stakes command center. Or, maybe it's a sprawling high-end retail space.
Oh, yeah. Tons of screens everywhere.
Right. All around you, you have dozens of perfectly synchronized, flawless 4K screens. Have you ever stopped to wonder how a system processes gigabits of uncompressed video data per second without, a single frame drop?
It's pretty wild to think about.
It is. And doing all that while relying on software simple enough for an intern to operate. So today's deep dive focuses on exactly that, the hidden infrastructure powering that multi-screen world. Specifically, we're unpacking the tech behind the SmartAVI HDR-UHD-32X32-S matrix.
Because, we just expect these visual spectacles to work flawlessly. But moving from those glowing displays on the wall to the actual physical box hidden in the server room, well, it reveals some really intense engineering.
Yeah, the physical footprint alone is just wild.
I mean, we are talking about a unit that handles 32 independent inputs and 32 outputs simultaneously, pushing Ultra HD 4K video at 60 Hz.
And it's practically a behemoth. You have a 25-pound piece of hardware pulling 100 watts of power, carrying a price tag well over $13,000.
Which is a serious investment.
Exactly.
Yeah.
To understand how it handles that kind of heavy-duty traffic, I usually think of a Grand Central Station model. Perfectly routing dozens of high-speed trains to 32 different tracks at once.
That's a great way to look at it. But rather than routing trains on shared tracks, this operates on an internal non-blocking crossbar switch.
Wait, non-blocking? What does that actually mean in practice?
Well, the non-blocking architecture is really the critical mechanism here. Unlike a standard network hub where data packets fight for bandwidth and cause stutter, this matrix establishes dedicated point-to-point electrical pathways.
Oh, so for every single signal.
Exactly. No two video feeds ever share a lane. That is how it eliminates latency and data collision entirely.
Which I guess explains the seamless switching aspect, because usually when you switch sources on a commercial display, you get that frustrating 2-second black screen. Right.
Right, while the monitor tries to handshake and lock onto the new resolution.
Yeah, and sync the frame rate. It's so annoying.
Well, the SmartAVI bypasses that completely. What actually happening on the circuit level is continuous ED'd management.
Okay, ED'd management.
Yeah, since professionals are often mixing legacy hardware with modern 4K feeds, the matrix has integrated stalers that force the display to hold its sync state. Meanwhile, the box just swaps the video payload underneath.
Wow, so it preconditions the signal before it ever hits the screen?
You got it. It matches resolutions on the fly, so the switch is mathematically instantaneous.
But sustaining that requires an incredible amount of raw throughput. Like the specs show an 18 gigabits per second backplane.
And you really need that massive pipeline for uncompressed 4.4.4 chroma subsampling at 60 Hz.
Which is a lot of numbers.
Right.
But if you've ever looked at a massive data dashboard and noticed the red text blurring or bleeding against a dark background, that is color compression failing you.
Exactly. That 18 gigabits ensures full color bandwidth, so tiny text on a command center wall remains razor sharp.
But I mean, with hardware this heavy-duty and expensive, my mind goes straight to configuration. Doesn't it require a team of specialized engineers just to turn it on?
It is such a common assumption that enterprise grade has to mean punishingly complex to operate. But in high-stakes environments, operators during a crisis simply do not have the time to punch in IP routes or write scripts.
So they needed to be simpler.
Exactly. The device is actually entirely plug-and-play with no extra drivers required.
Wait, really? No complex network installers?
Nope. They have this free HDR-UHD Manager Windows software, and it uses a completely intuitive click-and-drag interface.
But why rely on a completely graphical interface for something so critical? I mean, a web-based GUI seems like it would introduce massive security vulnerabilities compared to, say, a hard-coded command line setup.
Well, they thought of that. The system mitigates those security concerns by allowing local TCP/IP web control on an isolated standard PC workstation.
Oh, so it bypasses the open internet entirely.
Exactly. It just acts as a remote control for that massive crossbar switch we talked about, giving operators preset screen modes and unlimited custom layouts.
So an operator can just drag a camera feed to a screen icon, and the 25-pound box does all the mathematical heavy lifting in real time.
Right. The true engineering feat isn't just the raw power. It's hiding all of that enterprise-grade complexity behind a consumer-friendly interface.
It seamlessly bridges the gap between massive processing power and human-centered design. The technology executes billions of operations a second, so the end user doesn't have to think about a single one of them.
Yeah, maintaining the illusion of complete simplicity, even under maximum load.
That is incredible. So the next time you walk into a venue and find yourself surrounded by perfectly synchronized Ultra HD displays, take a moment to look around. Ask yourself, where in this building, behind some locked door, is the 25-pound brain hiding that's pulling all the strings?